Hi everyone, today my group from Group 11 will present about atomic hydrogen arc welding and types of welding electrodes. Atomic hydrogen arc welding, also known as AHAW, is a type of arc welding process that uses two non-consumable tungsten electrodes and hydrogen gas to produce very high heat for welding metals. The main purpose of this technique is to create a strong and clean weld, especially for high quality metals such as stainless steel and alloy steel. As shown in the diagram, the process begins with DC power supply connected to two tungsten electrodes. These electrodes do not melt during welding because they are non-consumable. When electrical current flows between the electrodes, an electric arc is formed in the middle. Next, hydrogen gas is supplied through the welding torch. The heat from the electric arc separates hydrogen molecules into atomic hydrogen. This reaction produces an extremely high temperature flame which can reach around 4,000 degrees Celsius. The high heat generated is then used to melt the base metal or workpiece for welding. The blue area shown in the diagram represents the hydrogen shielding envelope. This shielding protects the weld area from contamination by air, oxygen, and moisture. Because of this protection, the welding result becomes cleaner and stronger. Another important part shown in the picture is the base metal, which is the material being the weld. The heat from the atomic hydrogen arc melts the surface of the metal, and when it cools down, a strong joint is formed. In summary, atomic hydrogen arc welding is a welding technique that uses tungsten electrode and hydrogen gas to generate very high heat to precise and high quality welding. Although this method is less commonly used today, it is still important in understanding the development of modern welding technologies.
Okay, so my name is TIBAN. So now I'm going to talk about the procedure of hydrogen atomic arc method. So we have 5 procedures. So the first one is preparation, where we will clean the base metal, set the tungsten electrode with a small gap which is 1 to 3 millimeter. Then start hydrogen gas flow. The second is arc initiation. So apply DC power. Arc is struck between the two tungsten electrodes in the hydrogen atmosphere. Next is arc stabilization. The arc dissociates hydrogen molecules into atomic hydrogen, forming a high temperature flame which is around negative 4,000 degrees Celsius. So the next is welding. Heat from the atomic hydrogen arc melts the base metal. Filter rod may be added if required. So the next is solidification. Move the arc along the joint. When finished, stop power and hydrogen flow. Allow the weld to cool and solidify.
As is shown in this diagram, there are two tungsten electrodes connected with opposite polarity. The upper electrode is negative, while the lower electrode is positive. When the electric current passes between the two electrodes, an electric ARC is created in the gap between them. Around this ARC area, hydrogen gas is supplied continuously. The purpose of the hydrogen gas is very important. When the ARC temperature becomes extremely high, the hydrogen molecules split into atomic hydrogen. This process absorbs a large amount of energy. Then, when the atomic hydrogen comes into the contact with the workpiece or cooler surface, the atom recombine into the molecular hydrogen. During the recombination, the stored energy is released as the intense heat. This produces a very high temperature flame, approximately 4,000 degrees Celsius. In the center of the diagram, we can see the atomic hydrogen ARC, also called a plasma. This plasma is the main heat source used in the welding process. Because of the extremely high temperature, the base metal melts quickly and forms a strong weld joint. One important advantage of this process is use a tungsten electrode. Tungsten has a very high melting point, which allows the electrode to withstand at the extreme heat without melting easily. That is why electrode is called a non-consumable electrode. Unlike another welding method, The electrode here mainly create ARC and are not used as a filler material.
Now I will explain the advantage and the disadvantages of atomic hydrogen arc welding. First, let's look at the advantages. One major advantage of this welding technique is that it can produce a very high temperature heat. The temperature generated is extremely high, which allows strong and deep welding on metal surfaces. Because of this, the weld joint becomes stronger and more durable. Next, atomic hydrogen arc welding produces clean and high-quality welds. This happens because hydrogen gas acts as a protective shield around the welding area. It prevents contamination from air, oxygen, and moisture, which helps improve the quality of the weld. Another advantage is that there is a less contamination during welding. Since hydrogen works as a shielding gas, the weld area remains cleaner compared to some other welding methods. This makes the process suitable for precision welding work. In addition, this method is very suitable for welding stainless steel and high alloy steel. These materials require strong and clean welds, and atomic hydrogen arc welding can provide good welding performance for these metals. However, atomic hydrogen arc welding also has several disadvantages. The first disadvantage is that the equipment is very expensive. The welding system requires special equipment and hydrogen gas supply, which increases the overall cost. Secondly, this process requires skilled operators. Workers need proper training and experience to control the welding arc and handle the equipment safely. Another disadvantage is that the welding process is slower compared to modern welding methods, such as TIG or MIG welding. Because of this, it is less efficient for large-scale industrial work. Lastly, atomic hydrogen arc welding uses a large amount of electrical power due to the high heat generated during the welding process. This can increase energy consumption and operating costs. In conclusion, atomic hydrogen arc welding provides strong and high-quality works, but it also has a limitation such as high cost, slower speed, and high power usage.
Okay, now we are going to talk about welding electrodes. So welding electrodes consist of two parts. The first is the core wire, which is the metal, and the next part is coating. So the coating composition are fluxes, stabilizers, deoxidizers, binders, and alloying elements. So welding electrodes are rods or wires used to join metals through welding. They are classified into consumable and non-consumable types depending on whether they melt during the welding process.
So I'm KHAIDIR. So next we gonna talk about the type of welding electrodes. Looking at this slide, we can see that all welding electrodes are divided into two main branches. On the left we have consumable electrodes. These are electrodes that are consumed and melted during welding. And under this branch we have three types: SMAW, shielded metal arch welding. This uses a coated metal rod when the arch forms between the electrode and the workpiece. It is widely used, versatile, and economical. Second is DMAW or MIG welding. This uses a solid wire electrode that are fed continuously through the gun. It requires shielding gas and is known for high productivity across many metals. Next one is the FCAW, flux core arch welding. This uses a tubular wire filled with flux. It works with or without shielding gas and performs well on the thick material and outdoor conditions. Now moving on to the right side of the slide, the non-consumable electrode. These are electrodes that are not consumed during welding. Two types. The first one is tungsten electrode, used in GTAW or TIG welding. Non-consumable, used for the inner gas shielding and produce clean, high quality welds. Second is the carbon electrode used in carbon arch welding. The arch form between the carbon electrode and the workpiece and is commonly used for cutting and heating. So as you can see from this diagram, this slide, the type of electrode you choose depends on whether you need it to melt into the weld or simply generate the arch. Now let's look at the common type of welding electrodes, and this time we're going to go through each one visually, row by row at this table. As mentioned on the left side, previous slide, welding electrodes are classified into consumable and non-consumable based on their function. Consumable electrode melt and become part of the weld, while non-consumable electrode only produce the arch without melting. Now let's look at each type. At the first row, SMAW, looking at the image, you can see it is a coated metal rod. That coating is what provides the shielding during welding. The arch forms between this rod and your workpiece. Second row is a GTAW or TIG. Notice how this electrode looks completely bare and smooth. That's because it is a tungsten electrode. It doesn't melt, it just creates the arch while inner gas protects the weld zone. At row 3, GMAW or MIG, you can see this a solid copper coated wire. It's fed continuously through the gun as you weld, which is what makes MIG welding so fast and efficient. At row 4, the FCAW, this one looks similar to MIG wire, but notice the difference. There is a tubular wire with flux inside. That internal flux, it is what provides shielding and create the slack layer on the weld. At the last row, the SAW, this is also a bare wire like MIG, but it operates underneath a blanket of flux, which is why it called submerged arch welding. That flux blanket covers the entire arch during welding. So looking at this table, each electrode has a different look and specific purpose. The more familiar you are with how they look, the easier it is to identify and use the right one on the job.
So this is application of several ARC welding process. First is SMAW or stick welding. This welding method is commonly used in construction, repair and maintenance work because the equipment is simple, portable and suitable for outdoor use. Next is GTAW, also known as a TIG welding. TIG welding is mainly used for thin metal, stainless steel and aluminium. It produces clean and precise weld, making it suitable for high quality and friction work. The third process is GMAW or MIG welding. This method is widely used in the automotive industry, sheet metal fabrication and pipeline work because it offers high productivity and faster welding speed. Next is FCAW, which is standard for flux core ARC welding. FCAW is commonly applied in the structure steel work, heavy fabrication, and outdoor welding because it can perform well in harsh working conditions. The fifth process is SAW or submerged ARC welding. This process is suitable for welding thick plate and long seam, especially in the shipbuilding and heavy industry. It provides a strong weld with a deep penetration. Lastly, we have carbon ARC welding. This method is mainly used for going in, cutting, and metal removal application rather than precision welding. So in conclusion, different welding processes are selected based on the type of material, thickness, working environment, and production requirement. Each method has its own advantage and specific industrial application. Thank you.